In this lecture, we are going to discuss a popular data mining technique called decision trees. Decision trees is one of the most popular supervised data mining techniques in business analytics. Its appeal lies in its transparency and the ease of interpretation for business managers with even little statistics training. The algorithm for developing decision tree models is the classification and the regression trees, or CART. As the name suggests, the algorithm can develop both classification trees whose target variables are categorical or class memberships, and the regression trees whose target variables are numeric. Therefore, decision trees is a technique that can be applied to both classification and prediction data mining problems. The output of the decision tree model is a set of if-then rules, which eventually lead to a classification or prediction result. For example, if the goal is to classify cases into either the will respond to offer class or the will not respond to offer class, the rule may be something like that. If age is greater than or equal to 50 and income is less than $50,000, then class equal to 0, or the case belongs to the non-target class, which is the will not respond to offer class. As you can see, the rules are easily understandable by people with little statistics training, and they are easy to implement in practice. Furthermore, the reasoning behind the classification or prediction is described clearly in the rules. Even though decision trees is a data-driven technique, it does not offer a black box solution as many other data-driven techniques do. Therefore, it is very popular in business analytics. In addition to the easy-to-understand rules, part of the output of a decision tree is the tree diagram, which is the visual representation of the rules. This figure shows a simple tree diagram. The tree diagram resembles an upside-down tree, with the root at the top of the tree and the leaves at the bottom of the tree. The ovals and the rectangular boxes in the tree diagram are called nodes. The single node at the top of the diagram is called the root node, and the rectangular boxes at the bottom of the diagram are called leaf nodes. All ovals between the root node and the leaf nodes are called interior nodes. The root and interior nodes represent decision points, where a logical comparison is made based on the data to determine whether the branch on the left or right of the node will be followed next. For example, the root node in the decision tree here suggests that if age is less than 50, then move on to the branch left. And if age is greater than or equal to 50, then move on to the branch right. As is customary, the branch left usually represents the less than, whereas the branch right usually represents the greater than or equal to in the logical comparison. However, this is not always the case in different software products. You will need to pay attention to the different convention used for drawing decision trees when using the software product. The rectangular boxes, or the leaf nodes, represent the final classification or prediction. For example, the rightmost leaf node shows will respond, which is the class membership of the cases that land in this leaf node. if you trace back to the root node, you can piece together the rules that lead to this leaf node. The rule is, if age is greater than or equal to 50 and income is greater than or equal to 50,000, then the customer will respond to the offer. As you can see, a decision tree is easy to understand and implement. No wonder it is one of the most popular data mining techniques in business analytics. Decision trees are applicable to a wide range of business applications. For example, determining whether a customer should be given a loan, determining whether a prospect will respond to an offer, or flagging a credit card transaction as a fraudulent charge. While decision trees can be used for both classification and prediction, it is most widely used for classification problems. In this lecture, we will first discuss classification trees for classification applications, and then regression trees for prediction, and finally, we will discuss a contemporary extension of the decision trees technique called ensemble tree models. Since decision trees is a supervised learning technique, data partitioning is an important step in building a decision tree. The process of developing a decision tree model includes two important parts: growing the tree and pruning the tree. The tree growing process is achieved using the training data set and the split search algorithm, which we will discuss in detail later. The training data provides the previous cases with values of both predictor variables and a target variable to facilitate computer learning, and the split search algorithm will continuously partition the training cases to identify data patterns for classification or prediction. However, the tree models developed through this process often tend to overfit, which means fitting the training data very well but failing to generalize to unseen datasets such as the validation dataset. Therefore, to optimize the complexity of the tree model or identify the simplest tree with the best predictive performance, we use the validation dataset to prune the tree model, which means removing branches of the tree to make it simpler, but fit the unseen data better. The simplest tree with the best predictive performance on the validation dataset would be the final tree model. To summarize the process, the dataset will be partitioned at least into a training and a validation dataset, but sometimes a test dataset may be involved depending on the process or software product used to build the decision tree. For example, if a holdout method is used, then the training dataset is used to grow the decision tree, and the validation dataset is used to prune the decision tree, and the test dataset is used to evaluate how well the tree model will perform on previously unseen datasets. However, if the cross-validation method is used, as in a lot of the R applications, then the training dataset will be used for both growing the tree and pruning the tree, and the validation dataset will be used to evaluate the performance of the tree model on unseen datasets. Later in this lecture, we will provide a detailed discussion on both tree growing and pruning processes.